Assalamualaikum and a very good day. We, Group 1 from HD3, will be presenting question number 7. But before that, let's meet the team. Starting from the left, we have Ian Glenn, Faiz Haziq, Anissa, Iza Nadia and Irene Natasha. In this video, we are going to introduce ethylene glycol, its properties as automotive antifreeze, calculations to find freezing point and boiling point, and lastly, comparison of ethylene glycol and ethanol.
Good day, I bid to all. I'm in Glen LRM Florence, matrix number U21013988 will be introducing you to the compound ethylene glycol. Firstly, let's have a look to the compound. As you can see on the diagram represented, it is a colorless compound as well as odorless, but also a toxic organic compound. It has various uses, but the two main functions are it is used as a material for polyester fibers manufacturing and also antifreeze formulation. Some info about it: this compound has boiling points of 197 degrees Celsius and exists as liquid in the atmosphere. It also has molar mass of 62.1 gram per moles. Next, as you can see in the ethylene glycol line structure and 3D structure, it consists of two carbons, which is suitable for its name ethylene, which stands for two carbon in the compound. Also, we can observe that there are two hydroxyl groups attached to the compound. These are closely related to the reason why the compound name contains glycol, which simply refers to two OH groups attached. It is named as ethane 1,2-diol or 1,2-ethane-diol in IUPAC nomenclature and have the molecular formula of C2H6O2 or the simplified version in bracket CH2OH in bracket 2.
Assalamualaikum warahmatullahi wabarakatuh and a very good day I bid to all. I, Anissa binti Zuraimi with matrix number U21022213 will be presenting further about the properties of ethylene glycol and their role as antifreeze in automotive industry. Automotive industries require engines in order to enable the machineries to function, and engines, as we know, work by burning fuels, which cause the engine to produce heat when in use. Therefore, coolant is required in order to regulate the engine's temperature. Antifreeze is a liquid which is mixed with coolant to increase the boiling point and lower the freezing point of the coolant mixture. Ethylene glycol is one of the most frequently used antifreeze in this industry. So there are three properties of ethylene glycol that enable it to act as antifreeze, which are: first, ethylene glycol is miscible in water; second, ethylene glycol has low freezing point; and third, ethylene glycol has high boiling point. So let us look at the first property. Ethylene glycol is miscible in water. Ethylene glycol has hydroxyl groups in its structure, so it is a polar molecule, and ethylene glycol is able to form hydrogen bonds with the water molecule, which cause ethylene glycol to be miscible in water since water is a polar solvent. So for the next property, ethylene glycol has a low freezing point. Pure ethylene glycol has a lower freezing point, which is 12 degrees Celsius compared to water, which is 0 degrees Celsius. But once these two compounds are mixed together with their respective composition, for example, 60% of ethylene glycol and 40% of water, it will produce a coolant mixture with lower freezing point. Therefore, the coolant mixture will be harder to freeze at extremely cold surrounding. Next, ethylene glycol has a high boiling point. Pure ethylene glycol has a higher boiling point, which is 197 degrees Celsius, compared to water, which has 100 degrees Celsius. But the mixture of both compounds will produce a coolant mixture with boiling point that is higher. Therefore, it is harder for the coolant mixture to boil and is able to regulate the motor engine's temperature.
Hi, I'm Faiz Haziq Ismail, matrix number U210194, and today I will be doing the calculation part. So without further ado, let's just move on to the question. So the main objective of this question is to know what is the freezing point and the boiling point of a solution containing 651 gram of ethylene glycol dissolved in 2505 gram of water. Firstly, we can see that the given data are the mass of water and the mass of ethylene glycol. And since calculating freezing point or boiling point needed molality, so we have to search for it first. So how to search for molality? It is easy, which is mole of solute over the mass of solvent. So we don't know the mole of solute first, So we have to find the mole first. To calculate mole, we have to divide mass by molar mass. So since we have the mass of ethylene glycol, which is 651 gram, we have to divide by the molar mass, which is 62.1 gram per mole. And then we will get the answer 10.48 mole. After we obtain the mole, then we can find the molality, which is 10.48 mole divided by the mass of solvent, which is water, 2.505 kilogram. And then we will get the answer 4.18 mole per kg. Since we have obtained the molality, we can calculate both boiling point and freezing point. So let's just go one by one. So the general formula of boiling point is delta TB equals to KB times molality. KB is equal to 0.512 degrees Celsius kg per mole, and T naught B is 100 degrees Celsius. So we can just plug in all the data that we have, and we will get the answer of boiling point, which is 102.14 degrees Celsius. For the freezing point, the formula is quite the same, which is delta TF equal to KF times molality. KF is equal to 1.86 degrees Celsius kg per mole, and T naught F is 0 degrees Celsius. Then we can just plug in all the data that we have. We will get the freezing point to be negative 7.79 degrees Celsius.
I am Irene Natasha, matrix number U2100951. Today, I am going to explain the ethylene glycol versus ethanol. As mentioned before, ethylene glycol is more preferably used as antifreeze compared to ethanol. Why? The first reason is mixture of ethylene glycol has stronger intermolecular forces. As we can see from the picture, ethylene glycol has two hydroxyl groups which can form more hydrogen bonding with water molecules. As for the ethanol, it has only one hydroxyl group, thus less hydrogen bonding can be formed. Let us make more comparison to have better understanding. Ethylene glycol has two hydroxyl groups, as mentioned before, and has stronger intermolecular forces. This can dissolve in water easier since it can form more hydrogen bonds. Mixture of ethylene glycol and water has higher boiling point and can withstand higher temperature compared to ethanol. It also can absorb heat more efficiently, whereas the ethanol has only one hydroxyl group. Thus, it can only form one hydrogen bond with other water or ethanol molecules. It has weaker intermolecular forces. This will make it harder to dissolve in water since less hydrogen bond can be formed. Mixture of ethanol and water has lower boiling point, which makes it cannot withstand higher temperature. Mixture of ethanol and water also has lower specific heat capacity, which can absorb less heat compared to ethylene glycol. Now we are going to discuss about usage of antifreeze in winter and summer. During summer, the extremely hot temperature of the surrounding causes the car engine to overheat. Thus, antifreeze increase the boiling point and the specific heat capacity, which allow the coolant to absorb more heat and prevent the engine from overheating. In winter, the temperature is so cold that the coolant is freeze easily. Thus, antifreeze will lower the freezing point and allow the coolant mixture to work efficiently without freezing. That's all from us. Thank you.